Thank you for coming out. So we appreciate you all coming out to hear our talk, and hope we've got some good content for you. My name's Tim Smith. I'm in the core data engineering team at Goldman Sachs, and I run a group which advises our internal engineering and business customers how to design their data models, how to choose the data architectures, and how to integrate with the various data technologies that we select. We build those out in our data platform. We'll talk through how that happens. I'm presenting today with Abhishek and Nilabja. They work on building that platform, and particularly on integrating data sets that we purchase from external vendors into the firm. And we're particularly interested in announcements that have come out around Polaris Catalog, Iceberg, and various other formats which get us into a world of using more open data formats. So today we're going to take you through a story of how we've used those technologies and how that forms a part of our new Lakehouse Legend platform, which is essentially the latest iteration of what we think about of our data lake, but also our analytics and our data discovery and data processing environment. So we'll talk about how the current platform works, what the problems are with it. We'll talk about how I plan to use the new Snowflake features around open data standards, and we'll give you an application and data set example of how that links into consumption of market data and generation of insights on top of that. So what's wrong with the current platform? We love rebuilding systems, we're engineers, but why now, and what are we going to change? We have got a very wide range of data products in the firm. We have thousands of engineers, something like 8,000, 9,000 engineers, and they've been working for years to build and build and build and build. We have a large data lake. It's based on Hadoop. It's got Spark-based processing mostly. Most of that Spark is not, at this point in time, a good choice. About 90% of it is basically linear transformations. About 10% of it probably does need Spark or some kind of nonlinear or more complex calculation. But this was built, designed 10 years ago, built 7 or 8 years ago, at the time when we were struggling with the capacity of single machine relational databases. We were hitting the capacity of single machines, and big data was the theme back then. It's not really what we want anymore. A lot of people ingest data into this data lake. Significantly less people consume data from the data lake. And a lot of folks have their own analytics stack, which they would use to consume the data, or they will consume data from their operational systems instead. We've had a lot of improvements by mirroring that data into Snowflake, which solves one of the consumption problems, but there are still issues with data collection. We copy too much data. We have a lot of Kafka streams. We have a lot of processes which take data from one place and materialize it into a different form. We have too many processes which go and find reference data or dimension tables and do those via a procedural lookup rather than a linkage of data. We want to adopt technology faster, but in order to do that in our current systems, we have to make big decisions. We have to decide that I'm going to select this technology, I'm going to upload everything into it, and I'm going to stick with it for a few years. We have increasingly stringent requirements around data quality, around data lineage, and around data entitlements. Those are driven just by modern best practices of managing data. They're driven by our regulatory environment, and they're driven by the security and InfoSec environment in the current world. And finally, we have a particular requirement which seems to be specific to financial services, but I think is an interesting point for anybody, which is that our regulators want to know very clearly what our plan is if any of the vendors that we depend on change their model, go out of business, become too expensive. So they want to know our resiliency and recovery plans. So telling them that we think this one product is super cool, we're going to use it for everything, we're going to build on top of it, is great, but that's not good enough for them. They want to know, what if that goes away, what are you going to do? And that plan can be, I'm going to hire 1,000 people and they're going to type the data into a different system. There has to be a plan. So we have to be able to prove we can execute it. So we need to be able to move if we can. Not tomorrow, but we need to have a plan. So what we really want to do is have the ability so that our data processing is not so much data that we put in a database and data that we ingest, leave in one closed ecosystem, and then consume from the same place. What we want instead is data that we can process with a query engine, and then access that data from multiple places, and then have the option to process that data in multiple other places as well. So Iceberg provides us with a few different things. So at its core, Iceberg has got Parquet storage. That's great, that's fine, that's what we quite commonly use in a number of different cases already. But it's enriched. So Very simply, and I'm not going to get too technical on Iceberg, but I think of Iceberg as basically Parquet plus metadata plus catalog. The metadata is essentially what holds together our data lake, our platform. There is some sort of standard, some commonly used default metadata, but very, very importantly, we attach our own metadata about where the data came from, the process that loaded it, and various information that means that my data platform, when it puts that data down, can pick it up in another part of the platform and reuse it later. So very important when we talk about using Iceberg, we don't just write a file and then leave it there. We have a file specifically that's managed with one of our client libraries so that I know I can get it back. Importantly, I can deploy that client library anywhere. It's not particularly thick, but it does make sure it does have to have my metadata, not just anyone's metadata. You could think about using it externally with perhaps some more flexible data, but we make sure our own is standard. Second, we've got the catalog, and the catalog is the big thing that provides what we're looking for, which is interoperability between different services. When we say catalog, we mean more than just what you might think of as a discovery catalog, more than the ability to list all of your data sets and know where they're stored, although it is the core part that will generate that. We mean a catalog that goes all the way down to the core of database processing, so that you genuinely could write data from one query engine and have another query engine be able to understand that, be able to understand what's necessary for transactionality, for performance optimizations, and to have essentially a multi-stage data pipeline which processes data in multiple parts. We can understand partitioning, we can understand the milestoning of our data. So let me take you to sort of the outline plan, and then once I've given that, Abhishek's going to go into a bit more detail on that. Okay, so the starting point here is that we write some data in Snowflake. We've selected Snowflake as the first query engine that we're going to start writing data with, although the future plan is that we will write with other query engines as well. Not too many, but a small number which will give us some optionality. So the first deployment that we've got, it writes data with Snowflake, and now I've got some Iceberg files. These ones, to start with, they're using Snowflake managed Iceberg, and they are cataloged in the Snowflake internal catalog. We've also got essentially development code that can use the Glue catalog, and we've got development code that can use the Iceberg REST catalog, which will shortly be upgraded to use Polaris, which we think will be a fairly easy lift to start with, and then we'll have a lot of feedback for Snowflake on exactly how that works, I'm sure. But the first stage, we write data in Snowflake, and now I've got an Iceberg file. Great. The very first thing we do is we're just going to read it back in Snowflake. So you've got Snowflake as the writing query engine, Iceberg files in the middle, and then I'm going to read it back and run analytics in Snowflake. That's opened things up a little bit for me. It's solved the problem so I can talk to my regulators. I can say, I've got those files, they're my files. If I wanted to, I could go and rewrite those. I could process them in AWS, process them in another engine. It doesn't really open up anything in terms of operability yet. So what I then need to do is I need to start building read-only solutions on top of that. So then I will find other query engines, and I will start reading back that Iceberg data with those. So I might write a Lambda at AWS, or I might use single store, or I might use some other product that comes along, some new AI open source or vendor product that means that I can consume that data. So the read-only operation is the first thing. We can get a bit more complicated. I won't go into too much detail, but whether you want that data to be synced, whether you want it to be synced into caches, things like that. You can imagine that starts to open up options for performance, so I can select the best product that would operate for performance and scale. The next stage is to start to write in other places. So you can imagine I've got a data set which is written in Snowflake and read in another query engine, and now I can join it to a data set that's written directly in that query engine. Perhaps I can also write that back to Iceberg and I can sync it. So you can imagine I start to build up this graph of data flowing in different directions. Importantly, every single data set will always only be mastered in one place. I'm not talking about bidirectional writes. I'm not talking about something where I can sort of send things into some crazy hub where things magically resolve conflicts. We're talking about data sets which have got a primary source and then I can use in other places. So now I've solved my zero copy problem as well. I can choose to materialize data for performance reasons. I can choose to cache it. I can choose to replicate it if that helps resiliency. But I am not going to copy that data around just for the purposes of getting it into a query engine that I can use. Iceberg allows me to use it directly. Just a quick note on how we deploy this. This is our Legend platform. I'm not going to go into great detail on this today, but this is the platform that we use to deploy. If you would like to know more about this, you can go to legend.finos.org. And part of this is open source, part of this is internal. Essentially, the more mature the features get, we open source them externally. Our platform provides a semantic data layer, the ability to build data services on top, governance and catalog tools, and now the latest is that we're building the Lakehouse feature. I'm going to hand over to Abhishek now, and he's going to get into the detailed architecture.
Thank you, Tim. It's fantastic to be here. So I've been in the firm for about 18 years, and I've assumed various roles in data management, data warehousing, data engineering, every aspect. And my current remit is how to provide rapid, governed, and easy access to any sort of business users in the firm for third-party market data. Now, before we dive deeper into what we're going to show you today in a few minutes, let's talk about the user stories, how we used to do things, and where we are today. So in the past, one of the toughest jobs for any leader in GS is to execute on data-driven decision-making. Well, it's a conceptual thought, at the face value of it, it sounds simple, but it's not, right? So the actual execution, when you think of a data-driven decision-making, feels more like gambling than decisioning, right? So every leader has a secret sauce, and I'll tell you that. They can easily call anybody from the engineering, which is aligned to them, 2 weeks into the process, and they can ask them, hey, I need this XYZ data. Can you get this for me? I need that XYZ report, and I need to be in time for the presentation, which is due in a few days or a couple of weeks or whatever, right? When those kind of processes and conversations ensue, it's all about, okay, whom do I reach out to? Can I trade in for a personal favor? Et cetera, et cetera. And the questions abound from the business. Can I get access to this report? I have these two reports which are not able to reconcile. Oh, one is in euro, one is in dollars, right? Can I export this Excel to PDF quickly? Well, can I, quickly jumpstart from A to B by putting 3 VLOOKUPs in my Excel so I can transform that data quickly on my desktop, right? And the situation from the data engineering side of the story is, every data engineering team typically have a unique spin to solving these problem statements, right? So what becomes really challenging is, how do we come up with a central canonical model that can make these things progress forward in a sustainable manner, in a self-serve manner? So the whole idea is, can we change the status quo so that we can remove this practice of wheeling and dealing for 3+ weeks to kind of get access to the data and do insights generation? So that's when we wrote Legend. Really, it's a 3-tenet approach system. We want to give automated access to the data, so as much as self-serve as possible for users to come in, look at the platform, browse our semantic layer, scribble a query, and you can go to town with it. Second is governed and quality assured. If there is an X data element in a model, say interest rate, it should mean exactly the same thing, whether you're a trader in sales and trading, an analyst in asset management, or the CEO. And lastly, velocity, quick access, as much as middlemen that we can cut. So this vision was simple. It's always daunting to execute it, right? So when we combined Legend with our Lakehouse, which is based on Snowflake Data Cloud and Iceberg, as Tim mentioned, we could see how we're going to solve this problem. And what we're going to do is we are going to allow business users to come to one platform, and so that they don't have to ask questions to engineers. They can just go there. They can combine 10,000+ different sources, where the work has been done upfront to describe those data domains, link them, and basically present with a low-code, no-code way so that they can scribble their own queries and self-serve themselves. So therefore, a business user never had to kind of wait for an engineer's bandwidth to figure out, what data they can access for, how much they're paying for XYZ vendor data license, et cetera, et cetera. In a demo in a few minutes, we're going to look at a user experience which is pretty centralized, unified, and self-served. So I've touched upon most of the things what we're trying to do in the Lakehouse. Really, as Tim mentioned, from a lot of copy approaches, we're going to a lot of zero copy approaches in our Lakehouse instance. If you see our Lakehouse, it's a universal single commercial storage layer, really, where we're trying to orchestrate rapid prototyping all the way to full production use cases. Of course, all the data sets that are being ingested in a fast manner in Lakehouse, There is a quality assurance behind it. You can have, a discovery catalog. You can see the lineage at an attribute level. All that good stuff that comes with Legend. So really, like the advantage, like Tim mentioned, we're going to present about the vendor data acquisition and transformation and distribution story today. So we have managed to reduce this entire end-to-end process from 15 days to 1 day, consistently across 900 plus data sources. In the past, there was always this challenge, who's going to do curation, which engineering team, where is the logic residing? It was so many repos, etc. That's all centralized, backed by Git, so you have different domains linked together in a neatly joined and organized way. And thanks to Lakehouse, based on Snowflake and Iceberg, it's all canonicalized and centralized in one place. We talked about the self-serve aspect that just comes with the nature of the Legend platform that we'll see in a minute in a demo. Yeah, I'm not going to spend too much time on this, as in the demo you will see how we are bringing a source producer model. So let's say an external data set that we have procured from a vendor partner. What we are doing on that in terms of transformations, data rotations, etc. And how do we make sure that it's easy and simple to consume in a fast and governed manner for an end user to do analytics on that. So we're going to take a deep dive on that in the demo. Of course, we are talking about vendor data here. So key things to note there is the access rights on the data, who can see what aspect of the data in the organization. So all that good stuff of entitlements, making sure that we know exactly who's querying the data, so all the usage stats, detections, and metering, this is all comes within the purview of the platform, all automatically self-served through Legend. Yeah, we really want to give a huge shout out to the dynamic tables team in Snowflake. I mean, they have made our life super simple, right? Really, like in many of the cases, when you try to procure data from external data providers, or you're getting data from some source, it's not guaranteed that you're going to get that data in the shape that you want. So it's possible that the data is coming in like an append-only mode with a lot of versions, but all you need is the latest version of the data. It's possible that data does not show you the time semantic, so you don't know how to make sure that you can rotate the data and make it like a time series. So there are several reasons. You might want to canonicalize date formats or time formats to consistent one format. You might want to rationalize a currency or a country column all to ISO 2 or ISO 3. So several reasons you want to do DTs. If you're not aware of DT, it's dynamic table. It's a declarative pipeline in Snowflake with just a SQL query. You can orchestrate a data pipeline. Very simple. So it has been a game changer for a lot of cases for us. We're going to talk about Legend Lambda in a second in the demo, but at a very high level picture, this is the way that we can express our intent in Legend. What is our query? What do we want to really search through? How do we want to combine different things? And then we want to expose that maybe as a REST service, maybe as an object sitting in Snowflake that you can run SQL on, right? All automatedly through one platform, which is governed, SDLC'd by Git, with like entire lineage that comes with it. You can query that metadata along with the data. This is a very simple diagram of, you get the data from a vendor, it's being shared into your environment. You're then joining that data to a bunch of other tables, Snowflake managed Iceberg tables, which is your own domain data. You're trying to express a semantic, and now you want to, in a secure way, share that information to other business units and lines of businesses in Goldman. This is what we're going to see today in a demo. So I'm going to hand over to Nilabja, but what you're going to see in the demo is a self-serve and unified way, and this is the kind of user experience that our business users really, really love, all thanks to our Legend platform as well as Snowflake Data Cloud.
Thank you, Abhishek. So I'm just going to take a minute or two to just explain like the different database objects in GS Lakehouse, which we are going to walk through this demo. So this is very simple. Think about it like a data engineer journey, a day-to-day job. When we have a third-party market data in GS Lakehouse, how do we tie it to different dimensions which are internal to GS, and how do we generate a data model which can be useful for various user personas across the firm, traders, portfolio managers, etc., etc. So the first database object we are going to look at is a vendor SEC filings shared view. So this is a view created on a table which has been securely shared via the Snowflake data sharing mechanism. And this contains data from Securities and Exchange Commission 10K to 10Q and 8K filings. This is typical companies' financial statements or some major events which are relevant to shareholders. So if we just inspect the schema a bit, so we can see some like SEC document ID, some CIK company identifier, some variable filing text, and we can also see the actual value of the form as well. So moving on to the next table we have. So as you can see, this is a table which is entity master table. Now what is really an entity master? Entity master is GSS curated all of the companies and entity information. So we have something called entity ID, legal entity identifier, CIK, country of domicile, and we have some additional milestoning, batch processing metadata as well. What is special about this table is this data exists in an Iceberg format in an external volume, and we have created a Snowflake managed Iceberg table on top of it, which him and Abhishek explained a bit ago. The third table we are going to look at is a price master. So price master is basically GSS view of all the curated prices coming from different exchanges, different external and internal data sources. We have our own proprietary waterfall logic on top of that. And so if you just inspect the schema, we have some instrument ID, some date, some currency, some price, etc. This is also a Snowflake managed Iceberg table sitting in GS Lakehouse. The fourth and final table we're going to look at is a security master. So security master is, you can think about it as GS's universe of all the securities of across all the asset groups. So there can be corporate bonds, equities, munis, treasury notes, etc., across all different regions and countries. And with security master, as you can imagine, the volume of the data will be gigantic. Like, so if a trader wants to do a granular analytical operation, the query performance will be very, very important. And so this is where a dynamic table really comes into play, because previously, if you have seen in materialized view, we could not join multiple sources. A dynamic table makes it possible. We can write a declarative pipeline which refreshes on a fixed interval, joining multiple sources with the right clustering keys. We are able to achieve a lot of optimum query performance. So we'll just take a look at the security master schema. So as you can see, very common, we have instrument ID, instrument identifier, asset group, etc. So now we have a fair amount of idea that these are our database objects sitting in Lakehouse. And as a data engineer and a data modeler, I am going to use Legend to model this data. So I'm going to go to a tool called Legend Studio. So in this Legend Studio, the first thing I'll do is I'll establish a database connection from Legend into Snowflake. So, and after establishing the connection, I'll open up a feature called SQL Playground, where I'll first try to explore the data, because right now I don't even know what is a security master, what is an entity master. I'm trying to establish those relationships to our SEC filings in the first place. So I have written a very simple query. So as you can see, I'm joining security master with price master, trying to get to see what is the schema, what is the data type, how do I figure out the join conditions, and so on and so forth. So once this exploratory phase is done, now I have a very clear understanding how to join different entities together. Now I'm ready to really write the model. So let me go to show you an ERD diagram. So in Legend Studio, in the semantic layer, I can really describe the relationships which I have just explored. So as you can see, the SEC filings are related to entity master related to security master related to price master. So this becomes a very powerful directed graph which can be traversed in any direction. So if I'm a trader, I want to go into the security master, I want to traverse to price master to fetch a price of a bond. Or if I want to find out like what are the bonds issued from various entities, I can go to a entity master and traverse to security master. So this allows us as data modelers to define the relationship once, which can be used multiple times. So our end users don't need to worry about 20 different joins, 20 different aggregations all the time. So once we have defined the model, let me first try to query it. So I'll right click on query, and this opens up a screen of what we call a Legend Query UI interface. So this is an interactive interface which kind of lets you explore the data model first. So if you see over here in the left-hand side of the panel, so I have entity master tied to security master. The joins are underneath. So the database objects are interlinked with the relationships that we have established. So we can drag and drop various fields into the middle panel. We can write our query expressions, sort and aggregations, etc., etc. So for the benefit of this demo, I have already pre-created a query to show you. So as you can see, we have some company identifier, country of domicile. I have taken some fields from the security master, like an instrument name. I have taken some fields from the price master and also the SEC filings as well. On the right-hand side of the panel, I have some filters where I have defined some parameters like an instrument name, SEC period, end date, etc. So if I just run the query, it prompts me to pass two parameters which I have defined. So I will pass an instrument name over here. Let me do that. I'll pass a filing period 01/01/2024, and I will run the query. So what has happened here is we have gone from the physical database model into a semantic layer where we have defined the entity relationship and the model we want to explore. And this is what we call a legend lambda. Now that we have defined the business expression, I want to save the query and I want to deploy it. Now, how do I really deploy it? So this legend lambda expression can be deployed in various modes. So one of them is definitely within a few clicks, we can create a REST API which can be consumed from various clients, be it a Java application or a Python client. We can easily do that. One of the modalities here is using a Snowflake user-defined table function to deploy the legend lambda as well. What does it really mean? So when this legend lambda is compiled, it is encapsulating a SQL statement. And when we deploy that as a Snowflake UDTF or a user-defined table function, a function gets created back in the Snowflake account with that same SQL logic encapsulated within. So when I click on Activate, what happens is we open up a screen called Snowflake Activator, where we define the database connection we have already established. We provide the function name, and when we click on deploy to sandbox, the function gets created back in the Snowflake account as well. So let me go back to Snowflake and take a look at it. Okay, so what has happened is we have the parameters which we had defined. Remember, we had an instrument name, we defined a date parameter as well, and we also had the return structure, same as we had defined in the legend lambda expression. And if you see here, the SQL is what has been generated by the legend to Snowflake transpiler, which has been encapsulated using the function. So there are a couple of advantages of deploying it as a UDTF. One is definitely if your user is Snowflake savvy, but they want to take the benefit of data modeling in the legend, your model can sit in legend because that gives you solid SDLC, the data governance, your data lineage is preserved, you know exactly what transformation has been made. You don't have to write 500 lines of SQL code to generate a report. You have all of the bells and whistles that are attached to legend. However, you can package that lambda as a Snowflake function, and you can just call this function to see what data you can get. The second advantage is now that we are bringing this legend lambda into Snowflake, it becomes a database artifact which can be shared to other Snowflake accounts. So for example, let me just try it out. So if you remember, we passed the same instrument name, AL2, and the same date, and we get the same results over here. So when this becomes a database shareable artifact, we can share this across other Snowflake accounts. So if our investment banking is using Snowflake, if our asset management is using Snowflake, I have created a centralized data model which can be used by everybody in the firm. So this is what exactly we are going to show. So this is just semantic SQL, some administrative SQL which we have written. But so if you just observe line number 23, what I have done is I have just created a share. I have just attached my function to the share. I have just shared to this share to another Snowflake account. And I'm going to the consumer Snowflake account. What we have done here is classic data sharing. We have registered the share. We have created the database out of the share. And as you can see, I can pass the same AL2 and the same date parameter, and I get the same results. So centralized legend UDTF can be shared across Snowflake accounts with all their SDLC behind it. Now this works very well for our intra-organizational use cases. Very great classic data sharing. What if we want to share it with some clients? We want to put some additional entitlement logic on top of it, or we want to write some additional application code on top of the UDTF that we have just defined. In that case, this Snowflake UDTF can also be shared using the Snowflake native app framework. Now, I'm not going to go into too much details on Snowflake native app because it's a very big topic, but just to demonstrate what sort of application logic you can implement using the native app. So imagine we want to create some sort of granular row level, function level entitlement. We have a contract with the client and we want to enforce some entitlement on which functions they can see data, which functions they cannot. So as you can see, this is a very simple table which just represents that. So this is a function name, this is an allowed account, and we have an allowed indicator which indicates whether we want to show data in that account or not. So, and imagine this is our consumer client, and what we have done here is we have encapsulated all of those entitlement logic in an application package in the Snowflake native app, and we have created a private listing out of it. And once we consume the listing in the client account, it sort of behaves the same way. We pass in the parameters, we can see the data. Now, what has happened is there has been some contractual modifications. There has been some changes in the terminations or so on and so forth, and we don't want the client to see the data anymore. So we will simply update the indicator to no. And what it does in my entitlement table is it just puts a no indicator against the account. And so if I go back to the consumer account and query the data now, so I will not be able to see any rows. So this is just a flexible model where a producer can granularly control an application and data. How is it shared with the client? So just to recap what we did here briefly. So we had different types of tables sitting in GS Lakehouse. We had Iceberg tables, we had Snowflake native tables, dynamic tables. We were able to model them, link them, interlink them using Legend Studio. We had a model defined. We were able to deploy the model using a Snowflake user-defined table function. And then we were able to share this function using the Snowflake classic sharing mechanism as well as the Snowflake native app infrastructure as well.
So
at the end of the demo.
That's fantastic. Thank you, Niladja. So just to connect that back into our complete picture, you can see Niladja's detailed all of the different Snowflake features we use internally. You can see that all originated from data outside our organization, flowed through, ingest using Iceberg, all of the features, dynamic tables, all of these, UDTFs, native apps to get it then back out of our organizations in a different package format. And you even saw dark mode at the end, which we've obviously flipped on very quickly. We think that the potential for those both external linkages and the way we deal with our internal consumers and additional analytics are huge when you bring in the Iceberg angle, and we definitely will be contributing to the Polaris catalog. So we'd be very keen to hear from anybody who's got ideas and would like to discuss that. And equally, you're welcome to check out our Legend product. We'd be happy to talk to anyone else who'd like to know more about Legend.
But yeah, this was a lot to digest, like multiple types of tables and mashing them and then sharing it out. Thank you again for coming in.